In this session, I will try to solve a problem. The given binary search tree problem using a dynamic programming approach. And after solving this problem, the output will be an optimal binary search tree. So this is how an binary search tree problem looks like. There will be a set of keys given. In the given problem, there are 3 keys, 10, 20, and 30. P of I represents the probabilities of successful searches. There are 3 keys, 10, 20, and 30. So there will be 3 probability values for successful search. So when will a successful search happens? A successful search occurs when the user is searching for either 10 or 20 or 30. Apart from these 3 values, if the user is searching for any other value, then it will be an unsuccessful search. So Q of I represents the probability values for unsuccessful searches. Unsuccessful searches. Now, you can see that P of I has 3 probability values, 2 by 14, 1 by 14, and 4 by 14. There are 3 probability values because there are 3 keys. 2 by 14 is the probability of a successful search for 10. 1 by 14 is the probability for searching key 20. 4 by 14 is the probability value for searching key 30. So these are successful searches and their probabilities. Now, apart from 10, 20, 30, other values also a user might search. Say, for example, the user might be searching for less than 10, any value which might be less than 10, which I'm going to represent as a dummy leaf node, which is called as E0. E0 represents all the set of keys which are less than 10. And this less than 10 values are not there in the binary search tree, so it leads to an unsuccessful search. And what is the probability of this unsuccessful search? That is given here by 2 by 14. This is the value 2 by 14, which represents the probability of unsuccessful search for E0. This is probability for unsuccessful search for all the keys in E1, E2, and E3. So there will be 4 dummy leaf nodes in the tree which represent unsuccessful searches. So E0 here represents all the keys which are less than 10, and all values less than 10 leads to an unsuccessful search. What is the probability of unsuccessful search? As per the given problem, it is 2 by 14. Then user may search for any value greater than 10 and less than 20. Again, these values are not there in the tree. So whenever greater than 10 and less than 20 values are searched for, it gives a result of unsuccessful search, and which is represented as class E1. E1 is the set of all keys greater than 10 and less than 20. Now, what is the probability of E1 unsuccessful search? As per given problem, it is 3 by 14. The probability of searching for a value greater than 10 and less than 20 and failing is 3 by 14. So as such, you have the given problem. So the given problem looks like this. You'll be given keys, you'll be given probabilities for successful searches, probabilities for unsuccessful searches. Always remember, if there are n number of successful searches, there will be n plus 1 unsuccessful searches. Now I have represented these values in the form of a table. Here, for each key, I have given a number, key number I have given. The keys are 10, 20, 30. I have given them numbers 1, 2, and 3. I have also taken a 0, but there is no key number 0, but still I have taken some 0 because keys are 3, successful searches are also 3, but unsuccessful searches are 4. There are 4 unsuccessful searches. So to represent this one, I have taken this 0. So key number 1, key number 2, key number 3. Probability number 1, probability number 2, probability number 3. For unsuccessful searches, again, probability number 0, probability 1, probability 2, and probability 3. Now, this is your given problem, and I have tabulated it. And you can also see that the given probability of P1, probability 1 is 2 by 14. But here I have taken only 2. So here there are 2 by 14, 1 by 14, 4 by 14, but I have only taken 2, 1, 4. Divided by 14, I have removed. This is for calculation simplicity. Otherwise, calculating 0.1 into 0.9 as such fractional numbers multiplying and all, it will be somewhat difficult. So for working out the problem, we'll remove the denominators. We'll take only the numerators. Then to solve this problem is nothing but use dynamic programming approach and generate an optimal BST. An optimal BST is the one which has minimum cost of the tree. So with the given keys, you can generate many number of BSTs, and each BST will have a cost. Cost of the BST represents the cost of the search operations. Now, whichever BST gives a minimum cost for searching, that will be treated as the optimal BST. And solving this problem is apply dynamic programming approach and generate an optimal binary search tree. And for generating optimal binary search tree, we are going to use these two formulae. You have to remember these. The first formula is a recursive formula. The cost of I, j. This is a tree with some nodes from ith node to jth node. C of I, j represents the cost of the binary search tree having ith node to jth node. This is what C of ij represents. And this is a cost function for the BST. Now, how to find cost for a given BST? And for that, we are going to use this formula. And this is a recursive formula because you have C of ij here. I am calling some function C. And to find out C of I, j, I am recursively calling the cost function C, but parameters are changing. Here the parameters are I and j. Whereas here the parameters are I, k minus 1. Here the parameters are k and j. So I'm recursively calling the cost function, but I'm changing the parameters. Okay, so this formula that you have to remember. Further, you have to remember how to calculate the weights. W of ij is equal to W of I, j minus 1 plus P of j and Q of j. This formula you have to remember. This formula you have to remember. Using these two formulas, these are the two formulas that represent the dynamic programming approach. So using these two formulae, we are going to generate an optimal BST. So this is how recursion works. This is the recursive formula for the cost function of BST. Now I'll start applying this recursive formula for the given problem. I'll write cost of 0, 3. I have written 0, 3 because you can see here 0, 1, 2, 3. So it is 0 to 3. Right? So I have taken cost function 0, 3. Now this 0 is the I value. 3 is the J value for the given problem. This is where your problem starts. Now how to find this cost of 0, 3? This cost of 0, 3 indicates the cost of a binary search tree where there are internal nodes from 1 to 3. Internal nodes are from 1 to 3. That means there are 3 keys, 10, 20, 30. So there will be 3 internal nodes in the tree. So 0, 3 represents that this tree contains 3 nodes from 1 to 3. But now you can ask me why I'm writing 0, 3. I can write 1, 3. Cost of 1, 3 I can write, but instead I'm writing 0, 3. This I'm writing because there is a dummy leaf node E0 that I'm adding into the tree. Few dummy nodes we have added into the BST to represent unsuccessful searches. So there is E0. So I'm writing 0 to 3 here. So once cost of 0, 3, I want to calculate, I have to apply the recursive formula. So what is the recursive formula? So you can see here minimum. That is, I'm going to find a few values and I'm going to choose the one with minimum value. Right? So here I have to first consider what are all the possible values for K. The possible values for K are greater than I to less than or equal to J. So you can see here minimum of, there will be a set of K values which are greater than I and less than or equal to J. So here I is 0, J is 3. So what will be the possible values for K? Greater than 0, less than or equal to 3. So that means the possible values for K are 1, 2, 3. So if you write here 0 to 3, here K possible values will be 1, 2, 3. Now, you have the formula here, cost of I, K minus 1 plus cost of K, J. Now you have possible values for K, replace K with each possible value. So I'm writing here C of I, K minus 1. This is where I'm considering K equal to 1. So K is equal to 1. Now in this equation, replace I, K minus 1, K and J. This is how I'm going to get cost of 0, 0 plus cost of 1, 3. This is the cost function if I'm choosing K value equal to 1. Choosing K value equal to 1 means I'm considering the possibility that key number 1, making it as the root of the tree. I'm trying to decide here among all the 3 values 10, 20, 30, which one of them can be made as the root. That is the choice that I'm making here in this step. So I'm trying to choose first key as the root and I'm trying to find out what will be the cost of the tree if the first key is the root. Then there is second possibility. I can make key number 2 as the root. That is K value I can choose as 2. Then within this function, I, K minus 1, K, J, replace. Then third possibility, I can make key number 3 as the root of the tree. That is, I am choosing K value to be 3. If so, I, k minus 1, k and j. This will be the cost of the tree. So I have three values here, three cost values. Each cost value represents the cost of the tree. I can construct three possible trees, starting with key 1 as root, key 2 as root, or key 3 as root. I can construct three possible variations of the trees. If I take key 1 as the root, what is the cost? If I take key 2 as the root, what is the cost? If I make key 3 as root, what is the cost? Find out all the three cost values. Find out whichever is minimum. Whichever tree gives me the minimum cost, that I'll consider as optimal binary search tree. And to this minimum value, once you find out the minimum value, you have to add weight of 0, 3. This total thing is going to give you cost of 0, 3. Now, how do I do this? If I want to find out cost of 0, 3, I have to find out cost of 0, 0, cost of 1, 3, recursion. I have to find out cost of 0, 1, 2, 3, again recursive function. 0, 2 and 3, 3, again recursive function. So totally, if I have to start finding out C of 0, 3, that is, I want to find out C of 0, 3, I'll have to find out all the previous values. Okay, so this table is needed to be filled up. The columns are I equal to 0, I equal to 1, 2 and 3. Each of this value represents the cost of the tree from I to j. Cost of I to j. Now take different values for I equal to 0, I equal to 1, I equal to 2 and I equal to 3. And the rows will be, you have to take up 4 rows and you have to fix the ij values such that j minus I should be equal to 0. That is j minus I, 0 minus 0 is equal to 0, 1 minus 1 equal to 0. So these are all the cost values. You have to find out where j minus I equal to 0. Then I have to find out cost functions such that j minus I equal to 1. So I can write 0, 1, where 1 minus 0 is 1, 2 minus 1 is 1, 3 minus 2 is 1. So j minus I equal to 1 for all these cost functions. In the same way, I have to find out all cost functions for the possibility j minus I equal to 2. So I can write 0, 2, cost function for 0, 2. 2 minus 0 is 2, 3 minus 1 is 2. So these are the cost functions where j minus I equal to 2. Finally, j minus I equal to 3, there will be only one possibility, cost of 0, 3. This is the final value that you'll be requiring. And for wanting this value, you have to calculate all the previous values that might be required. So the total table looks like this in a bigger picture. The columns will remain same, I equal to 0, I equal to 1, I equal to 2, I equal to 3. The columns will remain same. The rows will remain same, j minus I equal to 0, 1, 2, 3. Here you have to find cost of 0, 0. For finding cost of 0, 0, first you have to find weight of 0, 0. Right? So this will be the process for filling each cell in the table. You have to first find weight, then you have to find cost, then you have to fix the root key. Which key will act as the root, what will be the cost of such tree, and what will be the weight. So I have to first find out all the weight values. So I have highlighted here for your reference in red color, W of 0, 0, W of 1, 1, 2, 2, 3, 3, 2, 3, 1, 2, all these weight values. First I'll try to find, then I'll try to calculate the cost, and accordingly I'll fix the root. So initial values for the weights. So I'll start with the here row by row from top to bottom. I'll fill row by row. So this is how you are going to first fill the 0th row. I'm just filling up the weight values here. So weight of 0, 0, you have to take it as Q of 0. Weight of 1, 1, Q of 1. So you can take the table here. You have to see this table. And from here, you have to find out Q of 0. This is Q of 0. This is Q of 1. Right? So you can find the values here, Q of 0, Q of 1. Take these values and fill. Where do I have to fill? I have to fill here as the weights. So from the table, you'll take Q of 0, Q of 1, Q of 2, Q of 3, you'll fill the weights. This is the 0th row. From this, you have to calculate the next rows. So for that, so this I have filled up. Now, these weights I have to fill up. What is the formula? Formula for weight of I comma j equal to weight of I comma j minus 1 plus P of j plus Q of j. Okay, so we'll start writing. I want to find out this value, W of 0, 1. What will be its calculation? W of 0, comma 0. That is I comma j minus 1. So it is 0, comma 0 plus P of j, P of j plus Q of j, P of j plus Q of j. Okay, so now what is W of 0, 0? You can find it in the above row. W of 0, 0 equal to 2. What is P of 1, Q of 1? P of 1 and Q of 1 are here. So I'll try to write 2 plus 2 plus 3, which is equal to 7. That is what I have written here, 7. Now, I have to calculate the next part. I want to calculate W of 1, 2. W of 1, comma 2 will be equal to W of 1, comma 1. I, comma j minus 1 plus P of j plus Q of j. Now check what is W of 1, 1. From the above table, W of 1, 1 is 3. What is P of 2, Q of 2? P of 2 and Q of 2. 1 plus 1, which is equal to 5. This is the value that I have filled up here. So in the same way, you are going to find out all the remaining values and your total table will look like this with the filled weights. With the filled weights. So you can see that I have calculated all the values using the formula. Now, once weights are ready, you have to start filling up costs and rows. Again, from top to bottom of the table. So I'll start from C of 0, 0, R of 0, 0. Now, initially, all C of 0, 0, cost of 1 to 1, 2 to 2, 3 to 3. These values will be filled up with zeros. So I'm filling up. Cost of 0, 0 is 0, 1, 1 is 0, 2, 2 is 0, 3, 3 is 0. Whenever I is equal to j, the cost will be 0. Then the root will also be 0. 0, 0, 0, 0. This is because cost of the tree is 0. That means I have not yet filled up the tree. Now the tree is empty. I am starting with initial empty tree. If the tree is empty, its cost will be 0. There will be no root. So I am going to start with all the costs as zeros, roots as zeros. Now from here, we are going to fill up the next rows in the table. So this entire 0th row is filled up. 0th row is filled up. So I have to fill the first row. I have to find out cost of 0, 1. Cost of 0, 1. Actually, if you want to calculate, you have to calculate. You can write the formula like this, where cost of 0, 1 will be equal to the minimum of the possible values for k will be only 1. Greater than I and less than j, less than or equal to j. So my I here is 0, j here is 1. The possible values for k will be greater than 0 and less than or equal to 1. So I have only one possible value. Now I am going to write the cost. How I am going to write the cost? I'll write cost of I k minus 1 plus cost of k and j. This is the cost for k value equal to 1. If k is equal to 1, then k minus 1 equal to 0. This is I. This is k minus 1. Cost of I, comma k minus 1. Cost of k, comma j. This is the cost function for k value equal to 1. If other k values are there, you have to write for them also. But for now, no other cost functions will be there because k has only one possible value, 1. So I'll stop it here. Plus w of I, comma j. Now try to find out what is cost of 0, 0. Cost of 0, 0. See above row. It is 0. What is cost of 1, 1? It is 0. Then 0 plus 0, and I have to find out minimum. Plus, what is weight of 0, 1? Weight of 0, 1 is 7. So what is the minimum of 0 plus 0? It is 0. So this will become 0 plus 7. And total cost value will be equal to 7. That is what I have written here. I'm going to write here cost of 0, 1 equal to 7. And how did you get this cost? By taking which key as the root, did you get this cost of 7? That you have to consider what is the possible value of k. Now here, the possible value for k is 1. That means I have got this cost by taking key number 1 as the root. So I'm going to write 1 here. The cost of the tree is 7. Which key you are considering for the root? Key number 1. Now, once you have written this 7 and 1, in the same way, you are going to find out the remaining values. But the hint I'll give you, you don't have to calculate at this level. Whatever the weight is there, you take the same weight. Weight of 1, 2 is 5. Cost of 1, 2 will also be equal to 5. Here it will be 6. Whatever value is there as the weight, take it for cost also. You don't have to calculate at this level. You don't have to perform all the calculation. Then what will be the root value? Whenever you are writing root, so directly write 1, 2, and 3. This is how you are going to write. 1, 2, and 3. This first 2 rows, filling is very easy. The remaining rows, you have to do some calculation. So next, I have to find out cost of 0, 2 and R of 0, 2. I have to find these 2 values. If I have to find these 2 values, I'll start writing. I have to find out cost of 0, 2. Now, what are all the possible values for k? Possible values for k is greater than I, less than or equal to j. So there will be 2 possible values for k, 1 and 2. Now I'm going to find out what will be this cost. I'll write the expanded formula. It is cost of, I am taking k equal to 1, first possibility, and I am writing the formula. So cost of I, k minus 1 plus cost of k, j. This is the formula for k equal to 1. In the same way, comma, I have to write possibility for k equal to 2. So I have to write for k is equal to 2. Then I'll write C of I, comma, k minus 1 plus cost of k, j. Okay, I have written k equal to 1, k equal to 2. It is done. Plus weight of 0, 2. This is the total formula. Now find out what is C of 0, 0. I'm going to write on the top. What is C of 0, 0? It is 0. Plus what is cost of 1, 2? It is 5. 0 plus 5 equal to 5. No, comma. What is cost of 0, 1? 7. What is cost of 2, 2? 0. So this value here is 5. Comma, the next value is 7. Among these 2 values, which is minimum? 5 is minimum. How did you get the minimum cost of 5? By taking which value for k? I'm taking k value equal to 1. That is, I'm trying to make first key as the root, and I'm achieving the minimum cost of 5. So now this is 5. 5, the minimum value that you have taken, plus what is the weight of 0, 2? Weight of 0, 2, I have to find out, which is 9. What is 9 plus 5? It is 14. So what is the total cost of C of 0, 2? It is equal to 14. Now what is R of 0, 2? Ante which key you have taken for achieving this minimum cost of 14? I have taken key number 1. Key number 1. So in total, I'm going to fill up. I'm totally going to rub this, and I'm going to fill up 14 is the minimum cost of the tree till now, and the root is 1. I have taken root as 1. In the same way, I can calculate C of 1, 3. C of 1, 3 will be equal to minimum of, what will be the possible values for k? 2, 3. Greater than I, less than or equal to j. This will be the possible values for k. Now, there are 2 possible values. So I'm going to write 2 possible values. So for that, I have to write, first, I'm going to consider k equal to 2. I'm going to consider k equal to 2 and I'm going to write. So it is cost of I, comma, k minus 1 plus k cost of k, comma, j. Then I'm going to consider k value for possibility 3 and I'm going to write the formula. Cost of I, comma, k minus 1 plus cost of k, comma, j. This is the first part. The next part after finding minimum is you have to add w of 1, comma, 3. Okay, now I have to find out the values and find out the total result. What is cost of 1, 1? Cost of 1, 1. Cost of 1, 1. I'll see in the table cost of 1, 1 is 0 plus cost of 2, 3 is 6, comma, cost of 1, 2 is 5, cost of 3, 3 will be 0, plus weight of 1, comma, 3 is 10. Now, among these two values, 0 plus 6 and 5 plus 0, which is minimum? The minimum is 5. Now, how did you get this minimum 5? By taking the k value equal to 3. Now, what is the total cost? C of 1, comma, 3 will be equal to 5 plus 10, 15. And what is R of 1, comma, 3? It is equal to 3. So I'm going to write 15 and 3. Here I have got 14 and a 1. So as such, apply the formula recursively and you are going to come up with the cost values and the root values. So finally, you are going to find out the cost of 0, comma, 3, the last value that is required. Cost of 0, comma, 3. So how can I write cost of 0, comma, 3? What are all the possible values for k? 1, 2, and 3. So here, this is for k equal to 1. This is the formula for k equal to 2. This is the formula for k equal to 3. Plus w of 0, comma, 3. Now, I have got k equal to 1. I have got 15. The cost of the tree was 15. For k equal to 2, the cost of the tree will be 7 plus 6, 13. Then for k is equal to 3, the cost of the tree will be 14. Among these three values, there are 3 trees and 3 cost values. Which one is minimum? 7 plus 6, 13 is minimum. How did you get that 7 plus 6, 13 minimum cost? By taking which key? K is equal to 2. Now, the minimum value is 13. Add 14 to that, which is the minimum value is 7 plus 6, 13. Plus add 14, weight of 0, comma, 3, which will be equal to 27. So the cost of 0, comma, 3 will be equal to 27. And how did you get this minimum cost of 27? By taking which key? I have taken key is equal to 2. Right? So I will start. Now this table is ready now. Once this table is ready, from this table, I'm going to extract the information step by step and I'll start building the root. So this problem will be continued in the next session. From this tabulated information, I'm going to extract step-by-step information for building an optimal BST. And we'll continue this problem in the next session.